By the end of this video, you should know how to identify and resolve memory leaks in your Java code. More importantly though, you should also be able to recognize these leaks while you code and avoid them altogether. Howdy hackers and homies, welcome to A Hot Cup of Java. I'm your host Lexi, a full stack engineer with a specialty in Java. Today, we're going to discuss memory leaks. These are usually an easily avoided problem in Java, but they can be a real head scratcher if they manage to sneak into your code. So, what is a memory leak? Well, memory leak is the term we use for memory that's no longer in use, but the program still maintains and reserves it. This means the memory is still being used up even when we have no need for it or even access to it anymore. In Java, most standard variables are handled by the garbage collector when they fall out of use. However, the garbage collector can miss one critical type of data: streams. Making API calls, connecting to a database, or reading and writing a file are all examples of streams. They open a continuous data flow and track it in memory. If we don't explicitly close this data flow, the program will leave it open and tracked indefinitely. Even if the resource itself closes the stream, it'll continue to be tracked for the life of the program. Nowadays, forgetting to close your streams is the most common case for memory leaks in Java. Before we look at some code, just a quick concept check for you. We haven't specifically talked about it, but I'd like you to consider what you think the consequences might be if a memory leak was left unattended in a method that will run multiple times. I'd love to see your thoughts in the comments. And with that, let's hop into the code to check out some memory leaks and strategies to deal with them. So we're actually going to make a command line word processor today. What this is just going to do is it's going to take an input line and save it to a file. And then it will ask you if you want to write another line or if you want to exit. To start out, we just have our core main class with the main method and a little bit of welcome text. Another thing to note is that we do have a target directory that's empty right now, and this is where we're going to save our file to. So what we want to do is we actually want to do two other static functions. Actually, it's going to return a Boolean. False if it fails, true if it succeeds. And this one is going to get input and write. And let's right now just return false. And then we're also going to do another one. It's going to say write another line. So this is going to get the input as to whether or not we want to write another. And to check that, we're going to do a while loop. And we're going to break a cardinal rule. We're going to put hard-coded Boolean in there because we're actually just going to break out as we need to. So we'll do an if where if get input and write is false, meaning something broke, then we want to go into this. Or if write another line returns false as well, then we want to break out of our loop. And then once we're done, we're also just going to tell the user a nice little message of goodbye. Now, to get input and write, what we're actually going to do is first we want to prompt the user to please write the line you would like to save. Okay? And then we actually need to make a scanner. And this scanner takes an input stream. And so what we're going to plug in is the standard system input stream. This is the stream it's actually the same stream as this output. It's just a different type. This is the one that any input on the command line will go through this input stream. So output stream accepts arguments that you put in and it puts it on the command line. The input stream will take everything that happens on the command line and send it into your code. And so we want to use that, and then we're actually going to take a different function to write to the file. And so that'll return a Boolean as well. Write line to file, and we'll take the string input to write. And so right now, let's just return false. And then what we're going to do is pull this, and we're just going to pass up the result of write line to file, and we're going to take the next line on the scanner, which is going to be everything that you type until you type in the enter key to create a new line. And so in our write line to file method, we're needing to make a file writer. And let's just make that, and then our destination is going to be target, and we're going to make the file saved input.txt. Now, this does take, it throws an IO exception. So let's just throw that in a try catch right now. And we want to change how we're catching here. But also, we want to make sure we have an append flag set to true. This will keep it from overwriting the last input. And so what we're gonna change how this handles it. And we're just gonna print out the error message. And then return false because something went wrong. So we aren't going to try anymore once this goes. The false would carry upwards and carry upwards here. So we'd print the error, and then we would say goodbye. And so our file writer, we're then going to take, and we're just going to write our input to write. If no error has happened, then we return true. So now we just have to do the prompt for checking if we want to write another line. This will go also pretty smoothly, but we do have to make sure we get the proper inputs here. So what we're going to do is prompt for another line, and we're actually going to do a line break on this. And we'll just do a yes or no. And then this is where we'll take the input yet again. We actually don't want to do a full print line because we want it to be on the same line when they enter it. And so we're going to take the character, and we'll get our response will equal, well, I forgot to make my scanner. So we need a scanner, and we do system.in. And so let's take the next line on the scanner, we'll trim it, we'll make it lowercase just to make it sort of case agnostic, so to speak. And then we're going to grab the first character of the line. And that's going to be hopefully either a Y or an N. Whoop. And so we're going to do if response is not equal to Y and response is not equal to N either, what we're actually going to do is we're going to recurse this. Basically, we'll kill him with kindness. Just keep on asking. Otherwise, we will return response equals Y. So this will narrow it down where if it doesn't match this condition and require us to go through again, then it will either be Y or it will be N. And so we want Y to be true and N to be false. So we can just return that. And there we have it. This is all we really need for what our goal is. So let's give it a try. And we have, welcome to the command line processor. Please write your line to save. This is the first line. And so before we answer whether or not we want to write another line, let's go ahead and take a quick look. Can I not refresh this? I guess I'll write another line. Let's go ahead. And test line 2. And I think that's good. So we have goodbye, and let's go look at what's here. Oh, there's nothing written. So why wouldn't there be anything written? Let's take a quick look. So we have our file writer is calling the write operation, and then we return true. Now, what we know about memory leaks is that we have to close things. Obviously, you can both see it's highlighted, right? So it's actually telling us about the exact memory leak in a bit more of a direct way. It's saying to use a try with resources, but the first thing we're actually going to do is use close. So when we close it, that makes the stream no longer present. Or it gets rid of the IO stream. It closes it, and it will write all of the results. So when we don't have this line in place, then it won't let us. And we can prove this case that it's because it's not closing by if we actually have one of these open and we try to do something else with a file outside of the program, it won't let us. Let's take a quick look at what that result looks like. So let's write test line 1. All right. And now we're outside of that scope. We've written to our file writer, and we can see still nothing is written. So let's try to delete. And yeah, we'll refactor along with it. And we get an error that we cannot delete it. The reason we can't delete it is because the code is still holding on to it. Even though we've left this function here, we are still holding on to the input or the output stream and trying to write to the resource. So if we add a close call, you notice the highlighting goes away, and then we are all set to do it again. So now we will do test line 1. And we can see, would you like to write another line? Let's go see what's on there. We have test line 1. Yeah, let's write another line. Test line 2. And if we navigate through, we wrote another line. Oh, there's a small little bug. We should probably move the caret down 1 line when we write to it. So let's add that in before we forget. And now we can also sort of prove our case here that now we should be able to delete it even though the code is running because there's no streams currently attached and using the resource. We do the refactor, and ta-da, the file is gone. So now with this close operation, it's successfully working. However, there is a much more concise way to do this. As you might recall, when it was highlighted, it suggested we use try with resources. So let's look at what that looks like. Try with resources, right? And now let's actually put some parentheses here on our try block, and we're going to indent just for the sake of it. We're going to take this, and we're going to put it here. I am not actually a fan of that indentation. I thought I would be. And we don't need the semicolon because it's just 1 line. So what this is doing is that it is assigning the variable to writer inside of the scope of the try block. And by putting it in here, it's telling the code to take any of the variables declared here, which you can only declare variables that implement a close method. Any of the variables inside of here, once we leave this block of code, call that close method. So if we try it again, with the try with resources. And we don't need to do multiple lines this time. Might as well, though. Test line 2. We're going to go ahead and say no. And now let's go take a look at our file. And ta-da! So we didn't run into the same issues because the try block is automatically closing it for us in those cases. So those are the two ways you would close them. And really, the way to recognize it is if you have streams that aren't in a try with resources scope and aren't being closed, you need to close them. The program, as long as it's running, it will hold on to those resources, and it's called a memory leak because that's memory that will stay being used up. So in theory, if we were continually writing new lines over and over again with that leak, we're not saving any data, but then we're also opening up more and more and more streams, and that's going to use up more and more memory. I would show you that if I had a profiler. That's a special tool that comes with IntelliJ's enhanced version, but I don't. So one thing to note, though, is you notice we open all of these scanners with system in. And, I describe these as an input stream. So I said whenever you have a stream, you probably want to close them, right? So let's go ahead and do exactly that. Let's see what happens. So actually, let's start with this one because we're not doing it directly in the return statement, right? So we just use it here. So after it, we can just do scanner.close. Easy peasy. And now we'll also do Boolean result. And then we'll do scanner.close here as well. And then we'll return the result. And so now all of the streams that we're creating should be getting closed when we do it, right? So let's give it a shot. Let's see what happens. All right. And so test line 2. I think we're on 3 now, actually. And whoa, we ran into an issue. No line found, no such element exception, etc., etc. So what actually happened here? So an important thing to note is there is a distinctive difference between streams and the interfaces we use to interact with those streams. So underlyingly, when we call a scanner on an input stream, that scanner will then call close on the stream itself. So when we call close to close the scanner, it's going to close the stream that it's scanning. This, however, is the standard input stream. This is the input stream from the command line. It's static and it's final. And because it's static and final, there's no making a new one once we close it. So the scanners that take the default system input stream will not be scanners that we close, because then we can't scan on the input stream again. That stream is done because you cannot replace it with a new one. So in those cases, that is, I wouldn't call it, like, if I were to call that a memory leak, I would call it a built-in and intentional memory leak. That is more like a memory constant than anything else. So yeah, we want to close all of our streams except the ones that come in given in every program with the core Java language. And the best ways to do it are, well, you can call the close method, that's pretty given, or even better, try with resources. It makes it very readable. It keeps all of it more manageable, automated by the JVM. And that is the basics on detecting where memory leaks are and how to fix them. Alrighty, in this video, we've covered what memory leaks are, the most common way they happen in Java, and went over some ways to avoid them. Before you go, check out links in the description. You'll see the code we wrote here, but there's also a little challenge for you. I've written a program that has some memory leaks peppered throughout. Check it out and see if you can clean it up and make it nice and leak-free. Catch you later, coders.